All right, Gagana. Okay, yeah, now I can share my screen. Can you see it?
Yes, we can see it.
Okay, awesome. Thanks everyone for joining. I'm Eleonora. My today's talk is called Fooled by Data, Psychology of Data-Driven Delusions. So probably most of you have something to do with data. Probably you analyze data or at least use data for decision-making. So you don't need me to convince you that data is important for making good decisions. However, you can also be data-driven, analytical, and wrong. Data can also lead you to incorrect conclusions. And that's dangerous because you might have false sense of confidence when that happens. You think that the conclusion is data-driven, so you are overly confident in it. And that's the motivation for me creating this talk. I will be sharing many different examples tonight. Some of them are from readings, others are from my real-world work experience. I have 10 years of work experience in analytics and management consulting. So, I structured the talk according to the stages of analytical process that you usually have. First, collecting data, then actually analyzing data, and then finally interpreting the results. So let's dive right into data collection. First example is from history. It's a very famous example. Some of you might have seen it before. It's World War II, and American intelligence forces are asking themselves a question of where they should reinforce the planes. So some planes never come back, others come back with bullet holes. And they ask this question to the statisticians. Hey, where shall we reinforce the planes in order to increase the survival rate? Here, I would like to ask you, the audience, please feel free to send some comments in chat or use annotations. I would like to hear from you. There is a question about slides. I will not be able to share the slides, but feel free to take screenshots if you'd like to have a recording of the slides. Someone is asking where the crew sits. Yeah, that's probably the place where a crew sits. Strangely, no bullet holes over there, yeah. Okay, yeah. I see some right answers in the chat. So the most intuitive answer that you would give, someone would give right away is, oh, where the most bullet holes, that's where you should reinforce the planes, yeah? That's incorrect answer. The correct one, reinforce them where there are no bullet holes. And the reasoning is that if planes were shot in those areas, they were not able to come back. So fundamentally, what's going on here is that we have bias sample. We have survivorship bias in our data sample. Yeah, we only see part of the data set, while another part is missing from it. That's what we call survivorship bias. Okay, history is interesting for sure, but how about real world? Yeah, how about some examples from our real day-to-day lives? So here I have a few of them for you. One of them is business case studies. Usually they focus on successful companies. Yeah, this is just one example of books like that. So how the studies work is that they take examples of successful companies and try to find some similarities between them. What's wrong with that? Well, What if companies that did not succeed do actually pretty similar things as companies that did succeed? Yeah, it's survivorship bias once again. Other companies are just not there to tell their story, or actually maybe their stories are not interested enough to tell because they did not succeed. So you actually just not seeing them in the data set. Interesting fact about this specific book is that 10 years after it was written, 50% of companies shown in this book as successful ones were not so successful any longer. They fell short. Another example, serving existing customers. Yeah, so very often a company would have some CRM, some system for tracking customers. And when it's time to hear some customer feedback, they would just ask, they would contact those existing customers. Anyone wants to suggest what's the problem with that? Yeah, exactly. So people who were mad about your service, they left. Yeah, you probably will not be able to reach customers who churned. Or actually, if we think even a little deeper, how about those people who never became your customers in the first place? Perhaps they compared your product to competitors, and they had some reasons to select competitor products. You never even have them in your database. Yeah, so as a result, you have survivorship bias. You will have overly rosy picture of what the market thinks about your products. And you will never have that honest feedback that you need in order to really develop the product further. So anecdote here is that actually this is one of the reasons why companies hire consultants. Yeah, this outside view of objective party that's not interested, it's usually able to provide better, more honest customer feedback. Okay, another example. So this example is from credit risk modeling. A lot of financial institutions, like banks, create statistical models to predict who are going to be repaying the loan and who are not going to be repaying the loan. Yeah, the logic is very simple. Of course, you want to extend the loan only to customers who are likely to repay it. Okay, but then what happens next? Those customers who you extended the loan to will either repay or not repay it back. So you get feedback about your model performance. And you can judge pretty accurately of how the model is doing. Is it accurate? Is it not accurate? You can fine-tune the model. But there is a problem. How about those customers that you never extended the loan to because your model said they are not going to be good customers? Yeah, you are not getting that feedback for that subset of customers, potential customers. And something really interesting that I learned in one recent webinar is that some financial institutions would actually extend the loan to a random sample of applicants who their models predict not to repay it. And that's for the purpose of actually learning how well the models perform. Yeah. So is my model predicting accurately even for applicants who are not likely to default? If not, then it's time to fine-tune the model, to retrain it. Okay, different example. This is probably less intuitive than what we talked about before. Sometimes a trend in the data can be generated from the data selection process itself. Imagine we are on a campus of prestigious college. How do they select applicants to admit? Two criteria. One is sporting ability, another is academic ability. And just for the sake of example, let's imagine that there is absolutely no correlation between these two variables in the general population. Yeah, so they are randomly distributed. However, when we walk on the campus of that university, all of a sudden we can observe negative correlation. If you think a little bit about it, it starts to make sense. Yeah, imagine you see someone who is not so smart. You can probably make conclusion pretty confidently that they must be an outstanding athlete. Yeah, because the college makes selection based on these two criteria. So among the students, you will observe this negative correlation. In real population, in the general population, it disappears. So here, we should be careful not to overgeneralize the trend that we see into the general population. Excuse me. So how does this apply to the business world? I suspect that area where we might see something similar would be if you think about store performance. Yeah. For example, imagine a chain of fast food restaurants. Chain management is doing outstanding work, only keeping well-performing stores open. Yeah, they would monitor performance and then they would close down stores that are not performing well. Okay, what are the variables that can predict store performance? What affects store performance? Well, obviously it is location, and probably it's also managerial skills of the owner. So probably in some of those we could see this negative correlation, just as we see with this college example. All right. I hope it makes sense. This is certainly less intuitive example. Okay, let's move on. Now, data analysis. Many of you have probably heard this term data mining, and usually it has negative connotation to it. Does anyone have an explanation why is it perceived negatively? What's the problem with data mining? Garbage in, garbage out. Well, yes, but also even if the data is good, you can sometimes torture it too much. Oh, yeah, someone is, John is saying overfitting. Yeah, yes, yeah. False pattern amplification. Okay, so you certainly have some good intuitions here. So imagine that you are doing some hypothesis testing on a data set, or even just some simple cuts on the data, but you are doing them all possible ways. Yeah, cutting the data in all possible dimensions, 20 cuts, 100 cuts. Yeah, with large data sets, that's certainly possible. So what's the problem with it? If you use p-value of 5%, which is very typical, just by random chance, out of 20 cuts that you make, one is going to be significant. Yeah, just because of the random chance. So if you don't have a hypothesis with which you approach the data, if you're just checking all the possible patterns, something is going to show up as significant. You will eventually find some pattern, but it can be just due to random chance. And sometimes it's called p-hacking or answer hacking. Yeah, if you heard, there is replicability crisis in academic literature, especially in psychology. So that's related to that. You can try finding patterns in the data and then only show significant patterns, only show interesting patterns to your audience and hide everything else. And as a result, you have a beautiful story, but actually in reality, it might not generalize. You might be, or if you're predicting statistical model, if you're creating statistical model, then you might be overfitting the data. Yeah, that's kind of related term here. Okay. Another example. Sometimes you might see counterintuitive trend in your data. Like here, we have illustrative example of drug dosage versus recovery speed. Oh my goodness, seems like this drug is really bad for the health of your patients. Yeah, it's better to eliminate this drug completely. Well, not so quickly. If we break this down by a logical group, and in this case, it's age of the patient, actually all the patterns are positive. Yeah, actually the drug is helping patients to recover. So this is called Simpson paradox, and it has puzzled many very smart people. My recommendation would be to always try to break the data down by a logical group and only then draw conclusions. Yeah, the pattern might disappear completely, or in some cases, it might even reverse its direction. And now, example from business world. So imagine a company. They sell something to consumers, and they would really like to increase average order value. To do that, they run a large marketing campaign, and they spend 100,000 euros on that. Okay, so let's see how the data appears after this campaign. Oh, seems like for new customers, they were indeed able to increase average order value. Yeah, it increased from 130 to 156 euros. Great. For existing customers, similar thing happened. They increased from 250 to 300 euros per the average order value. Great. Success story? Well, yes, but then if you look on aggregate, the numbers become funky. Yeah, the average order value across all customers actually has decreased. So this is just another example of Simpson paradox. Yeah, what happened here is that the share of new customers increased dramatically in the customer data set. And new customers tend to have lower purchase value. That's why the average from across the data set is lower now. So if the analyst just calculated it on aggregate, if they did not break it down by new customers versus existing customers, actually you might draw a wrong conclusion that the marketing campaign was a disaster. Yeah, it hurt the business. That would be wrong. Okay, and now interpretation of results. Here is a fun example. And probably each of you is able to tell me what's wrong here. Anyone wants to be brave? Correlation doesn't mean causation. Yes, thank you. Yeah. It's fun to see it on examples like that, but still easy or tempting to make conclusions when you work with real data. Yeah, it's okay. But now let's go to examples that are a little harder than this. This was certainly very intuitive. So it's World War II once again, but now it's time for UK intelligence forces to puzzle. So Germans developed flying bombs that they sent from the shores of France and Netherlands towards London. And actually, many of them did end up hitting London. So the intelligence forces are asking themselves, like, hey, how sophisticated is the German technology? Are they really able to target it that precisely? And then from the pattern of areas that have been hit, can we make conclusions where German spies are? Perhaps they are targeting strategic locations and they are avoiding areas where their spies live. Yeah, that's what they were thinking when they were looking at the map of downtown London and seeing these concentrations of bombs on the map. So, of course, statisticians came to help, and they applied Poisson distribution to this data. So first they broke down the map into little grid, and then calculate the concentration of the bombs in different areas. And the conclusion was that, no, actually, we cannot say that this is on purpose. This pattern is no different from what random pattern would look like. So what's going on here? Actually, something very characteristic of the human brain. We love to look for patterns. Yeah, there have been even stories of people finding Holy Mary in a loaf of bread. We like to look for patterns and trends. And we actually have pretty poor understanding of what randomness looks like. So let's talk about randomness a little more. Imagine two students were asked to flip a coin 100 times and then to write down the results. So heads or tails. Here are those two patterns. And we know that one of these two students cheated. The other one did the job correctly. They actually flipped the coin and wrote down the results. Can you guess from this who of these students cheated? Okay, 2. Not enough runs, maybe. So those of you who are guessing student number 2, why do you think that? Many back and forth. Never more than 2 in a row. Yeah. Well, we have very smart audience today, indeed. Yeah, student number 2 cheated. Student number 1 actually flipped the coin. So actually, if you calculate probabilities of 3 or 4 of the same heads or tails being in a row, that's not so low. Yeah, it's not such a rare event. But somehow our humans' brains underestimate likelihood of these rare events to happen. And one example from real world, not from the business world, but from real life that I would like to make here is imagine a family who has 3 or 4 kids, all the same gender. I bet all the relatives, all the neighbors will be guessing why they all are the same and then making a prediction for what gender the next kid is going to be. Yeah. Oh, you have 4 girls, that's because you eat too much cabbage. And the 4th one ought to be a boy. Yeah. Well, if we studied probability theory, we know that, well, gender of the next kid has nothing to do with genders of previous kids. It's still about 50-50. Yeah, but for some reason, it's really tempting for us to make those suggestions. So we underestimate likelihood of rare events. Okay, now some examples from business world. Honestly, this is example that I've seen in real life. I'm not making it up. So here is some pattern for the number of safety accidents in some plant per year. And the conclusion that someone would really love to make is our safety records are improving. We are doing better. Anyone wants to suggest what's wrong with this conclusion? Small samples, yes, not enough data points, yeah. And I mean, surely 1 is better than 4 safety accidents, but maybe you would like to wait 1 more, 2 more years till you start making some conclusions. Yeah. Okay, another example, also from the business world. So at Bain, we really like metric that's called NPS, or Net Promoter Score. We ask respondents in the survey, how likely are you to recommend a certain company or product or service to a friend or relative or colleague? Yeah, and then we record the answer on the scale from 0 to 10. Then what's going to happen is that we will analyze this data. We will calculate the delta between percent promoters and percent detractors. And that's what we call NPS. So it can vary between plus 100 to minus 100%. And obviously, the higher, the better. It's a great measure for customer advocacy. Yeah, how loyal, how positive customers are about your brand, and how does it compare to competitors? Okay, but now imagine someone is doing a study like this, but it's a B2B company, yeah, so business to business company. And when it is B2B, it's pretty hard to collect large sample, yeah, because the number of customers for your product can be just very low. Okay, so here are some illustrative data. We can see that the score for our company is higher than that for the competitors. Awesome. Our company is industry leader in customer loyalty. Yay, we are the winners. Yeah. Any problem with this conclusion? difference might not be significant. Thank you, Michelle. Yes, that's obviously correct. Yeah, sample size is just small. So when your difference, when your effect size is so small, you should be really careful when drawing conclusions. I have actually calculated confidence intervals about around our estimates. And here you can see how wide they are. Yeah, you can actually draw no conclusions at all about how our company compares to the competitors. Unfortunately, the sample size is just too small. So be careful when analyzing small differences in the data, especially on small data sets. Okay. Last example. We trust complex models. This is an example from early in my career. I was doing some price forecasting, and I created a model that, well, yeah, it was on the simpler side. And the forecast it was creating was kind of naive. So it was relatively flat, no fancy pattern, no cyclicity or seasonality there for sure. Okay. I went to show the forecast to my business stakeholders. They looked at it and fair enough, they said, hey, can we improve the model? Okay, I went back to my desk and I tried to work a little more on this model. And I tried to incorporate in some additional leading indicators into my forecasts. That seemed to work. I had a model that looked a bit more fancy. As a result, my business stakeholders quickly judged that it was much better. But, well, those of you here who are familiar with statistical models would probably quickly tell me that, oh, no. Actually, the first model was probably better. Yeah, I have probably overfitted the data with the second model. Exactly, someone is saying bias variance trade-off. Exactly that. Yeah, but think what happened here. Actually, second model is probably worse. It's even dangerous to use. Yeah, when you have models that overfit the data. They will capture signal, they will capture noise in the data, and they will make the forecast based on it. Actually, I would feel much more confident if I was to implement the first model in production instead of the second one. Yet, my business stakeholders felt much more confident when they saw the second model. Yeah, and that's what called sometimes complexity bias. We have this psychological phenomenon that just makes us feel much more confident when we when we see some mathematical precision, something complex and precise. And that's very dangerous. If you think about the global financial crisis in 2008, actually it was partly driven by exactly the same patterns, same thinking patterns. Bankers created complex risk management models. We thought that they knew what they were doing. Of course, the models were so sophisticated, so they must be very precise. It's all safe, great. But actually, any model is based on assumptions, and it is as good as the data behind it is, and the data can be biased. Sometimes we should be a little humble when we look at the outcome of statistical modeling and remember that model is just a tool and it's never a perfect tool. All right. Yeah, over-engineering features in machine learning. Exactly, Tel. Yeah, this would be an example of that. Okay, so we went through all the examples that I wanted to show you. Great, we are done. Well, not quite. I have some final notes for you. So some of you might be thinking, well, yeah, this is interesting, but I would never make any mistakes like this. I've been trained in statistics. I've read some book about behavioral psychology. No. This is for other people. Yeah, I'm a rational being. Well, I have some bad news for you, unfortunately. Can anyone here tell me who this person is? I'm sure someone will recognize him. This is a very famous person. Madoff, no, sorry, I don't know who Madoff is, but that's not him. Kahneman. Who is Kahneman? Daniel Kahneman, exactly, behavioral economist. Yes, thank you. So this person is the godfather behind behavioral economics. It's an area of science that studies how people make mistakes in their reasoning. Yeah, so a lot of the things that we were talking about today are founded by this person. Yeah, he did all the fundamental research that went into our understanding of how humans make errors in their thinking. So here I have two quotes from Danny Kahneman that for me at least were completely eye-opening. I don't think my thinking is much better than 40, 45 years ago when I started doing behavioral economics research. Teaching psychology is mostly a waste of time. Danny Kahneman. So what the godfather of behavioral economics is telling us is that it's very hard to think rationally. Yeah, we might read books, we might participate in webinars, but still we keep making the same thinking mistakes again and again and again. So this is maybe just a reminder for all of us that being rational is actually really hard work because irrational thinking, behavioral biases are just so ingrained in our human minds. All right. Yeah, if there are any questions, I'm happy to answer them. Favorite books, Thinking Fast and Slow by Danny Kahneman, Predictably Irrational by Dan O'Reilly. Yeah, they are some of my favorite books. Black Swan, yes, exactly. That's another one. Black Swan is amazing.
Well, thank you so much. We could definitely take some questions now. I mean, you've been doing that for a bit of time already. Oh, we have quite a few. They're just coming in.
Okay, let's do it. How did you convince your business stakeholders about choosing the model they did not think was good enough? So usually you should really test your model on the test set, not only on train set. And that would already provide a lot of proof for which model is going to generalize better. Also, I would say that actually business stakeholders usually prefer simple models. If they see something they can really understand, like a decision tree or linear regression, where they can see the drivers, they understand how they affect the predictions, usually they would prefer that to a black box model where they cannot understand the mechanics behind it. Favorite books. Okay, I can repeat it again. Thinking Fast and Slow, Predictably Irrational, and Black Swan. Business stakeholders hate deep learning. I guess there are different use cases for deep learning compared to some of the more of decision science or marketing science applications. Yeah, just the use case is a little different. In my world, usually simple models win. Here is an interesting comment. I struggle with getting stakeholders to let go of the idea that certainty can be found in more data. There is really good presentation about this from Andrew Ng, who is certainly very respected person in machine learning. So there is one school of thought saying that just improve your model and you will be fine, just make more complicated models. And another school of thought that says that work on your data, get more data, get better data. And he is certainly saying that you should be getting better data.
We have a question in the Q&A side. How can someone get better at communicating data?
Oh, that's a great question. Just give me a second.
Sherry says getting better data. If only.
So the question was about communicating better with data. Is that right?
Yes.
Yeah. So I think we are moving towards the topic of data visualization here. That's another topic that I'm pretty passionate about and that I did a lot of work about. There are a number of books that help you learn best practices and get intuition about things that work versus things that don't work. For example, Edward Tufte. I'm writing that name in the chat. So he has done a lot of work on that topic. There are other books as well, like Big Book of Dashboard. That teach you best practices of data visualization. Also, what I found worked really well for myself is Tableau Conference. either attending in person or they have recordings on YouTube. And a lot of them are really good and available for free in your free time. So they talk about best practices of data visualization a lot, and they give you intuition for what's effective versus what's not effective.
Gotcha. Although we have another question relatively similar to that, kind of giving a situation. Anonymous attendee says, when presenting to the CEOs of companies, a lot of rhetoric about dumbing down the data and focusing on visualization as they are not trained statisticians. Do you recommend these types of assumptions?
So I think the question is, usually when presenting to C-suite, the demand is to show something simple, yeah? Don't go into technical details, don't show much details, don't describe everything about you did with statistical models, but just show some summaries and communicate implications, yeah? So what does this data mean for my business? And yeah, do what your audience is expecting you to do, for sure, yeah? But it does not mean that you should not do due diligence and actually run proper analysis of your data on the background and make sure that those summaries that you are presenting, that they truly hold, yeah, that there are true basis, enough of evidence to say the things that you are recommending.
All right, awesome. Thank you. We have about 4 more minutes if anyone wants to get any last minute questions. What are excellent, Sherry's asking, what are excellent tech stack and languages for data visualization? Not talking about Tableau.
Stack for data visualization, Power BI is popular. Recently, I learned about Kepler GL. It's a free tool for mapping, really nice, high quality visualization that doesn't require code. Yeah, of course, you can also do visualization in Python or R. Honestly, I have not been a fan of that, because when you do things in tools like Tableau or Power BI, then you give freedom for your business stakeholders to co-create with you. Yeah, you can create something and it's interactive, and they also have enough knowledge to dig deeper, make some changes, and yeah, that works pretty nicely.